Well, I don't think it will.
Now we should be fine.
Yeah.
Okay. That's what I needed to do. Look, this best. This is so fun.
Think we're out.
Hey guys, you guys want to play the hardest game? You guys ready for the hardest game of Stickman ever? Or what is it called? Hangman? Hangman. You guys ready for this one? You're never gonna guess. Oh.
Well.
Now we know why. Okay. Board and master and snitches. We used this yesterday, so. Oh my gosh. All right. Yes, everyone you got it.
You got it, brother.
I do.
Do we have any
Lovely guesses for this impossible game of Hangman? E?
Oh
No
my
E's. Yeah.
C.
Oh.
There's a C.
S. S. There's one S. Any more guesses on our impossible game of Hangman?
We're getting an A.
Whoa! I need people to raise hands and not
Oh.
the same people. Yeah.
A.
Oh my goodness, there's one A.
What could it be?
All right.
No.
I need hands raised. Am I seeing any hands raised? I'm not seeing any hands raised.
I'll raise my hand.
Other numbers?
Huh?
Other numbers?
Yeah, there can be numbers. You want to guess a number?
I don't know. There's a lot of numbers.
Yeah, right. Guess a number.
All right, I'll go with one.
Okay, you were baited, but I believe you guys can get this in time. Does anyone want to just throw something out there so that we can make this game longer? I can't hear you. F's a good one right there.
Oh.
Do I start with the arms or the legs? This is an important decision. Arms.
Yeah, arms are good.
What is
Good. Oh, it's too late.
Epsilon. I'm trying to make the map bigger. I know what it is. Yeah.
I'm too lazy. Anyways. I don't want to say theta. I can do it.
Okay, theta. Fine.
Oh,
Any letter will do. I know it's not that letter.
Longer arms. Okay.
Okay, good.
Who wants? I don't have a feastable today, but does anyone want to get the last one? Someone who is 100% confident that they can get this last one. It's all on you if you raise your hand. Yeah.
I'm thinking P.
Oh. No P. You guys got one guess left in this near impossible game of Hangman.
Z.
You have one guess left, unless I'm making top hats. I'm making top hats. All right.
There's no Z.
There's no Z.
You don't cross this. There you go.
Maybe one of the new people. Parker, you got this? What am I doing? Game of Hangman. We're already at a top hat, okay? You got one guess left. This is near impossible. Near impossible. Don't mess this up.
I think it might be I.
It might be I. You guys think it's I? It's definitely I.
We won.
You guys win. You guys win. Maybe. Oh. Well, that's well.
Oh yeah, when
That
you
is-
drop it, it's like pretty much.
Ooh. Oh. Oh no.
They'll probably like there.
Oh no. That's like our one whiteboard might be.
That was the only working one, right?
To fish it out.
Oh, I have whiteboard markers. Oh my goodness. You're so right. I don't need your whiteboard markers.
Yes, they are.
Brand new whiteboard markers. All right. I feel bad about that. There's.
Okay, you can't. Yeah, it's why not?
Okay.
You need notes for this meeting because we just like. Just takes like general. We're gonna have slides. So like just general summary.
Right past. One. Yeah. All the time. In the market. Yeah. The doors are like. I could never figure out what was that. Yeah, Oh, I always. Oh, you did? Yeah. You rejected? Oh my god. That is faster. It's literally at any of the. Wow. Why are rejected? Somebody have like a plan. It's very reason not to. Yeah, but.
Just got.
It's really funny, we're like, we obviously,
Check out your tool.
like, no one realized what was there, like, oh, yeah. I was the only one.
Yes, yeah.
There's only one, maybe 2 days, kind of they actually asked, like, so I was like, basically look like. They have, yeah, group with them, like, we're gonna extend. Like, if I was like. Like the only actual, so there was a girl. Yeah. There's a guy that. Like actual videos the other way. Yeah. And then. Because like. These are that. So they were smelling, we have like, we got thrown into this, it's like the attribute based on. I guess like
certain meeting like 2 weeks ago, and then it's like we have that's the meeting.
And like.
Yeah, let's get involved in something. Yeah, it's like coming up with ideas and projects. Already. I'm gonna try to look at right now. How that connects to everything else in artificial intelligence. It's so broad. I didn't.
But like having that extra help that happens, like on top of it, that makes it like that 2 days in it's like that 1 day to break down. Yes.
I know there's a lot of work being done. Machine learning models more explainable. Probably not. Yeah. I guess things going up. So, it's really outside. I think it's already, I mean, it is already, I've been reading it. First, I went through the technology to I thought we had experts and I thought, okay, this is something I should learn about.
Yeah.
Oh, I was like, it's kind of weird. Yes. Yeah, I got it.
Yeah, related to the semantic search, like we're doing semantic search. Okay, so I guess we need to be able to eventually we're going to be working like that. It's also I took some data science before, and I took an AI in games class. That's why I learned some about evolutionary algorithms a bit, and yeah, exactly. I mean, there's the idea was that we're supposed to use these evolutionary algorithms to train robots to win at wars, or they leave a trail of hate. Yeah, and it worked terribly. So I'm reading about it. Seems like
Yeah, but you need to be very
Hello, hi guys. We're gonna get started in a minute here, but if you're interested in staying for the Git workshop and you do not already have a GitHub account, I just wanted to give a reminder to make a GitHub account right now. So just go to github.com and make your account here already. If you already have one, you're good. But yeah. Like 5 more minutes.
5 more minutes?
Like 4 more minutes. And I'll do this back. We're still fine, though. Well, Amir. You don't have to. You can sit wherever you like. Wait, it's true.
space that might be left. That's talent.
I don't Kurfess. You guys have said it's that way. Had like it's literally right That was for me. Yeah, like a chicken sandwich.
Oh, yeah. I can't into that. My wife wants to have your body. If I work on that, it takes, you know,
Nothing about it. Very good.
Yeah.
I like. Where are you talking about? Like. It's like. Okay, so giving meaning towards the church actually. Yeah. Storing knowledge. So actual giving. Like our game. You know. Same word.
Are you gonna stay up there?
Yeah, so you're finding the word.
No, I would probably just find a seat.
So we have. I would like. I mean, some girls. Yeah, that's fine. So we can create. I want to learn more about that.
All right. Hello, everyone. Welcome to our third meeting. We're super excited to have you here today. We have a really fun lineup. We have our guest speaker, and then we have a little workshop for you guys right after. So stay tuned for that. I hope that you all didn't have trouble finding this room. Was it like generally okay to get here? Yes. Yeah, we have a much bigger room now. We have updated tech, so super great stuff. We're recording the meeting also, so we'll send out the recording after we finish. So look out for that. But yeah, today we have our club advisor, Professor Kurfess, here to talk to you guys about artificial intelligence. Very knowledgeable guy. He's teaching 2 sections right now, 480, which is the introduction course to artificial intelligence here at Cal Poly. And then next quarter, he will be teaching 580, which is the graduate level course. So if you have any questions about AI, this can also be a reference for you. So without further ado, I will hand the presentation over to him to get started. Let's give him a round of applause.
Great. That's my title. Okay, here we go. Thanks, Amal. And thanks for inviting me here. I appreciate all of your interest in artificial intelligence. And before I go into artificial intelligence, a little bit about my person. Who can guess where I'm from originally? Yeah.
Germany.
Oh, you already. Okay, let's take it a little bit further. Any particular area in Germany? Kiel? No. No. Wrong corner.
Berlin.
Berlin? No.
Munich.
Closer. I studied in Munich, so I got my degrees from Munich, but that's not where I'm from originally.
Worm.
Worm?
Isn't Worm the city?
Worms, the swarms,
Worm.
swarms, yeah. No,
I'll find that one,
Munich,
but-
Munich is best so far. Has anybody heard of Albert Einstein?
Yeah, maybe.
Yeah. So he left Germany very early, and especially the town where he was born, which is the same town I was born in. Does anybody know where Albert Einstein was born? No, I didn't expect that. So it's a town about 100 kilometers from Munich, southeast of Munich, called Ulm, ULM, and it's famous for two things. The first one, Albert Einstein was born there. The second one, it has the highest church steeple in the world. So if you're ever there, try to climb the steeple. You can't go all the way up to the top, but it is quite a hike. So it's also a very nice view from there. So then Amir already gave it away. Germany, Munich is where I got my master's and my PhD degree. After Munich, I spent some time in Berkeley at the International Computer Science Institute. And then I spent some time back in Germany, then New Jersey Institute of Technology, Montreal, Concordia University. And then I saw the light, or my wife and I saw the light, and we realized we need to go back to California because Montreal is a beautiful city, but it's cold there in the winter. And they have lots of snow, and both my wife and I have been exposed to snow, but not to the degree that we would like to spend half our year buried under snow, not literally, but close to. So that's my background. I've been working in or around artificial intelligence for quite a while. My master's thesis was not about artificial intelligence, but I did my PhD on artificial intelligence and have been working in artificial intelligence since then. So how old do you think artificial intelligence is? How long has it been around? For those of you who were in my class already and know it, try to hold back. I'm here, yeah.
I'm on your class, but I would say as long as humanity has existed itself, because there were golems, like in myths and stuff.
Oh.
So
Okay. So, but you're using a very, very wide, expansive definition of artificial intelligence. If we use a narrower definition of artificial intelligence, how long do you think?
I think 70 years.
Okay, 70 years, so that's 50s, right? Okay, do you have something specific in mind? Why 70 years and not 60 or 80?
I kind of just remember something about the 50s.
Right.
AI.
Yeah, there is something that happened in the 50s in AI. Yeah.
Was that the Turing machine?
No, the Turing machine was a little earlier. So what happened in the 50s in AI in 1956, there was a workshop at Dartmouth College where about 20 or 30 people got together and they were using computers to do interesting things. And there somebody came up with the term artificial intelligence. So that's frequently considered kind of the birth of artificial intelligence, at least the term artificial intelligence. Of course, there was stuff going on that now would be called artificial intelligence way before then. If you narrow it down to using computers in connection with artificial intelligence, then it probably goes back to the 40s, 50s. And then that's the time, 40s, late 40s, early 50s, when Alan Turing also developed the Turing test as we still kind of use it. What else did Turing do? Yeah.
Didn't he make a computer, like the ones and zeros?
Yeah, the Turing machine. Yeah, that's also something he did. He also did something in artificial intelligence that, interestingly enough, did not use computers at the time. He developed a chess program, but they didn't have computers to actually run it. So he ran it in his head and verified that it actually works. So that's one of the very early attempts at using artificial intelligence with kind of computers, but not really running it on computers. Okay, so now let's go to the slides. Okay, so there are multiple definitions of artificial intelligence out there. A very general one is that a program tries to solve a problem and tries to find a solution for a problem. This is also sometimes visualized as a graph that describes the problem, and then you're finding a path from a starting point to an end point, a goal in your graph. That's a somewhat more narrow definition of artificial intelligence. There are also people who define artificial intelligence based on what humans can do. So you're trying to create entities, programs that do something that humans are good at, like playing chess or speaking a language or recognizing objects. And then there are also other attempts at defining artificial intelligence that utilize slightly other approaches. What we also frequently use in artificial intelligence is the notion of an agent. So an agent is an autonomous entity that can act on its own, and it usually has sensors that allows it to pick up clues from its environment, and it also can take actions. So it has so-called actuators like hands and feet and the mouth to speak that it can use to manipulate its environment and perform actions. And these agents typically are programmed by humans. Sometimes instead of writing programs and explicitly programming them, you could also use learning techniques, machine learning, deep learning, neural networks to train the agent. Okay, Tracy. That's machine learning. So I assume that many of you already have heard about machine learning or even have used machine learning approaches. So nowadays, this is fairly straightforward because you don't have to write machine learning programs from scratch. You just can use libraries and run libraries, and many of them are prepared as Jupyter notebooks or similar environments, where all you need to do is give them some input, press a button and say train on this input, and then it will do some magic and it will utilize its built-in and acquired knowledge to take an input, let's say an image, and produce an output based on what you've trained it on before. So, for example, if you do object recognition, you're trying to recognize digits, you train it on 10 digits, and then you give it a new digit, handwritten digit, for example, and it gives you its best guess based on what it has learned before. So this is machine learning. There's also a category of machine learning that does not use trained sets or training sets, labeled data sets. There's so-called unsupervised training, where you just give it some inputs and you ask it, sort these inputs out for me and try to find inputs that are similar to one another. So that's categorization and classification. There are methods that use that. Now, these machine learning programs are especially useful in situations where you have such sample sets and you can give them to programs to train them, and you don't really want to, or it's too difficult to explicitly write programs that do that. So one particular category of machine learning that has become especially popular is so-called deep learning. And deep learning essentially means that you have a relatively large machine learning system. The most frequently used ones are neural networks. There are others as well. And the deep refers to the so-called number of hidden layers that you have in such a neural network. So deep learning became very popular about 10 years ago and had several breakthroughs. And that happened because of several reasons. One of them is people developed better networks. So larger networks, more complex networks, more sophisticated networks. We also have better computers, especially computers that use GPUs, because a lot of this neural network stuff is essentially matrix manipulation. And then we also had data sets, and bringing all of these things together led to an explosion of deep learning systems and deep learning applications. So what kinds of examples have you heard about where deep learning is used? There are at least two broad categories that became very popular.
Computer vision, natural language processing.
Okay, computer vision and natural language processing. So in computer vision, what are some examples where you may have heard about deep learning? Yeah.
Object detection.
Object detection. Okay, so you have an image, there are objects in the image, and you identify, first of all, which objects are of interest. And then you may also try to recognize these objects. Is it a dog or is it a cat? And that's, for example, very critical in autonomous driving, because when your autonomous vehicle is driving around, it should be able to recognize the objects in front of it and then also distinguish between a pedestrian and a tree. So for the autonomous system, a tree is a very bad obstacle, because if it runs into a tree, it might get destroyed. A pedestrian for the autonomous system is a more flexible obstacle, because it can be pushed out of the way. Of course, it's not good to push a pedestrian out of the way. If you're a car, it has very bad consequences for the pedestrian. So the autonomous car also needs to realize and recognize pedestrians and say, oh, careful. In principle, I could run the pedestrian over, but that's not a good idea. We don't want to do that. Okay, so that's one example of deep learning in computer vision. Then Amir also mentioned natural language processing. I bet that many of you already have used natural language processing that is driven by deep learning. Okay, ChatGPT. So I'm not going to ask who has used ChatGPT. I assume that all of you have used ChatGPT. So what is the deep learning part in ChatGPT? Well, Amir, I believe that you know all of this, but let's give the other students also a chance. Yeah.
Doesn't it predict what the next best word is?
Right. Yeah. Okay. So I mentioned earlier that with deep learning, we have sophisticated networks. So there's usually a sophisticated network, a transformer, as it is called. Then we also have large data sets. What are the large data sets that natural language processing and ChatGPT may use? Yeah.
Basically like the internet or large parts of the internet.
Anything that is text-based or also image-based for the more recent version, or anything that it can find on the internet that it can digest or ingest. So it sucks up a lot of text-based information for natural language processing. It's also somewhat controversial, because a lot of that text-based information may be under copyright or intellectual property, and this is being sorted out. It uses this as an input. It is being trained on major computing systems, and it costs millions of dollars to train such a system. And then you give it an input, a prompt, and it spits out some output. So what's happening internally is that we essentially have a large statistical prediction system that takes your input, teases it apart, and tries to predict, based on this input, what are likely outputs, what are likely combinations of words that are related to this input. Now, this is a bit simplistic, because there's also other stuff going on in ChatGPT and similar programs. But if you look at the deep learning aspect of ChatGPT, that's essentially what's happening behind. So neural networks are relatively simple programs in principle, but they can also become fairly large, as in deep learning, and then become fairly sophisticated. There's one drawback that these neural networks have. They are black boxes, so it's very difficult to figure out what's going on inside these neural networks. There are tools that allow you to inspect them and essentially peek inside, but trying to identify what actually happens and why it gives you a particular output for a particular input is very difficult to determine. On the other hand, they work extremely well for certain types of problems, and they also have frequently extremely fast response times, so it doesn't take a long time to figure out the solution to a problem. Okay. So here you see a display of the different types of artificial intelligence. So neural networks is one of them. Then somewhat broader is machine learning. Machine learning is not only neural networks, there are other techniques as well. And then we also have artificial intelligence as a broader category. And there are a few more disciplines or sub-disciplines in artificial intelligence. So one of them, for example, is referred to as knowledge representation and reasoning, where you have basically programs that describe knowledge and how knowledge is structured, and then you take existing pieces of knowledge and you systematically generate new pieces of knowledge. That was the approach that was used for natural language processing until about 10 or 15 years ago. And although people spend a lot of time essentially describing the syntax and the semantics of languages, it did not work very well. So then they switched over and they used these statistics-based approaches, and with a massive data set and lots of computing power, all of a sudden these statistics-based and deep learning programs performed much better than the old-fashioned rule-based and knowledge-based AI programs. So frequently in artificial intelligence, it's easier to use simpler approaches, but of course, sometimes simpler approaches also have their drawbacks, like in many cases, if you use neural networks, they work after you've trained them, but sometimes they don't work, and it's very difficult to figure out what they can do. On the other hand, these symbol-oriented knowledge-based systems are much more difficult to construct. They require lots of human expertise, and they also require a lot of computing power, and frequently they don't have good response times. It takes a while until they give you an answer, but you frequently can trace why they come up with a particular answer. You can essentially look at the logs of these programs, or they have so-called explanation components, and they can tell you exactly why they give you an answer. So in that case, the complex system is actually easier to debug than the simple system, but the typical approach is to use simpler systems first. In artificial intelligence, we already addressed a few concerns. So one of them is the modern systems use a lot of information and a lot of input data that they can find on the internet, and they are not too concerned about who actually created it, who owns the intellectual property to it, who spent a lot of time creating and producing these texts or images, and how they can be compensate them. So this is something that is being sorted out. There are also biases. The data sets frequently contain more information or misleading information about a particular area. And so if you train a system on a biased data set, then you also get some biased output. Sometimes the systems, the algorithms are also biased, and you get output that is biased not because of the data set, but because of the algorithm. We also have safety and security issues. If you don't know what your system is doing, then of course it may do things that you're not, that it should not do. Another one is explainability. I mentioned that already. It's a black box. You don't really know what's going on inside. And so you can't really fully understand why it's giving you an answer that you may not be entirely comfortable with. We also have transparency issues. So what are the data sets that they are based on? What are the algorithms that they are using? And in some cases, especially when it comes to liability issues, like when a car hits a pedestrian and the pedestrian is injured or even worse, killed, whose responsibility is it and why did that accident happen? That's accountability and oversight. Then we may also end up in a situation where these tools, these artificial intelligence tools, are not available to everybody, only available to people who have access to it, so physical access, which requires computer access most of the time, or people who are computer literate enough, like all of us, and can use these systems. But there are plenty of people who either don't have access or don't know how to use them, and so they may be left out and left behind. We also have the issue that workers right now are doing some jobs that can be replaced by computers. So what happens to those workers? So we currently have strikes going on, or just finished strikes about Hollywood writers that may be replaced by artificial intelligence, and they were fighting for the right to be compensated for the work and not being replaced. Another strike is the United Auto Workers that also are somewhat affected by artificial intelligence. Then there's also education and public awareness. If you read the popular press, you frequently find doomsayer scenarios where people will say, oh, in 10 years, artificial intelligence will take over the world and we're doomed. It also frequently has dual uses, or it can be used for weaponization. There are activities going on to create military systems that are autonomous and intelligent. And militaries right now claim that they are still under the control of humans, but there are also scenarios where it will become effectively impossible to control these weaponized systems because the response time that may be required is so fast that it's impossible for humans to be in the loop. And of course, there's also the threat of so-called bad actors that develop these technologies or use these technologies and use them without being bound by moral or legal constraints. And then finally, there are cultural differences in some societies or in some parts of societies. These tools may be acceptable, whereas other parts of societies may not be open to using these tools. So there are quite a few questions when we use artificial intelligence. If you start, for example, training a deep learning system, then one question you should ask yourself is, if I have a particular data set, is this data set reasonably unbiased? So does it contain, let's say, images of broad categories of people, not only, as has happened in the past and frequently still happens, white males, because those happen to be the people who were predominant in that field when a lot of the technologies were developed. Then you may also have implementations that favor one outcome over another, not necessarily because you tried to do that, but because you didn't pay enough attention, and that's just what it happens to do. And it's important to be aware of such possibilities and try to explore other possibilities as well. Then how can you make sure that your model works for everyone, not only for the people with whom you happen to test your algorithms or your inputs, but for other people who may not be as easily accessible to you and who may have different properties from you? What are the consequences of my model not working? I pointed out a couple of severe consequences for object recognition, but you can think about similar consequences for natural language processing. So let's say you use a translation system and you're trying to purchase something, there's a mistake in the translation, and you buy something that you didn't want to buy. Is it your fault? Is it the translation system's fault? Is it the seller's fault because they didn't pay enough attention? So there are quite a few questions open that can happen if things go wrong. Then you also frequently with learning systems want to do what's called continuous learning. So you train your system, it achieves a good level of performance, and instead of leaving it alone, you keep on training it to further improve it. Sometimes it's driven because you want your system to perform better, but sometimes it's also necessary because the conditions under which your system works also change over time. So you need to possibly improve your system continuously. And then what can you do so that if somebody uses your system, does not use it for nefarious purposes? So I assume that many of you may be working on models or on systems that you make available on GitHub or some other platform, and anybody essentially can use it. Could somebody use it and do something that is illegal, immoral, unethical, that you don't like at all? Well, of course, but what can you do after you've put it out? So next, we'll look at a few slides that explore some applications of artificial intelligence. And for those slides, keep a few things in mind. So if we look at a particular problem, what kinds of AI solutions that I already have mentioned might be applicable to solve that problem? It's also possible that other approaches that I have not mentioned might be the best ones here. During the development or before you start working on such a problem, what kinds of ethical concerns should you keep in mind? So we'll look at a few examples now. Thanks, Jay. So Cal Poly, of course, has a major agricultural operation and school. And so one of the applications of artificial intelligence is in monitoring agriculture. Does somebody happen to have an agriculture background? No, I do. If I had strayed from the path that my tradition would have directed me towards, I would now be a farmer sitting on my tractor and driving around the fields in Germany. Fortunately, my younger brother turned out to be a better farmer than I did. And so for the farm and for myself, it was better that I ended up where I am now instead of on the farm. So my brother's farm is relatively small, so he's not really using a lot of artificial intelligence. He uses modern systems, so his tractor also has some artificial intelligence, but people use drones, satellite imagery, and all kinds of other things to observe the conditions of the fields and alert them to various things. So one is, are the fields ready for harvest? Another one is, did they get enough water? Did they get enough fertilizer? Did they get too much fertilizer? Is there something wrong? Are they infected by pests or some disease and we need to do something about it? So that's our agriculture. Then there's also car assembly. Most of you probably drive cars that have been partially assembled by robots. These robots that you see here are not really very autonomous systems. They are directly programmed and under the control of an overall system. But there are also so-called collaborative robot systems where humans and robots work together. Those collaborative robot systems are more sophisticated, more difficult to program, but they have a higher degree of autonomy. So the example here takes over some heavy-duty work where you have to lift the door and place it in the right place and attach it to the car. And if you do that all day long, and these doors weigh maybe 50 to 100 kilograms, that's not good for the back. So that's an example where robots can take over work that humans are not really made to do, and they can be used in such a way that they don't completely replace human workers, but help human workers make their job easier. Then customer assistance, when you call for service and instead of talking to a human, you actually are greeted by a virtual assistant and they ask you questions and then you probably realize, well, no, that's not really what I want. And you press the magic button. Sometimes 0 works on your phone and you talk to a human because they are much better at helping you solve your problem. On the other hand, virtual assistants are getting much better. Some of them are now also powered by ChatGPT and similar technology, and they frequently can answer questions that are relatively straightforward and where humans get very, very tired about answering. So, for example, we have some collaborations with universities in Germany, not only because of me being from Germany, but we have an exchange program with the Hochschule München, so one of the universities in Munich, and they are working on chatbot that helps with the advising of students. So if you go to your advising center and you ask somebody about which courses to take, then you're asking a question that hundreds of students have asked before, and the answer is always the same. So the advisors understandably get tired about it. On the other hand, you as a student probably want to know because that helps you make decisions. So this kind of questions, routine questions that can be answered relatively easily, can be taken over by virtual assistants. Then a purchase predictor for a customer that may be annoying, but also helpful. Let's say you're going shopping, you're frequently doing your shopping online, and your favorite online store already knows what you're going to buy. So you don't need to bother putting everything in your shopping cart. You just press the purchase button. Isn't that nice? Well, it can be nice, but of course there's a hidden agenda frequently. They do not only want to predict what you're going to buy, they also want to steer you towards the products that they want to sell. Yeah.
So it's just like, I guess, same kind of quotes of groceries.
Yeah.
Would it be better if they just had like a history of it, so the customer could just, just select their history?
Right, yeah. Of course, that's also relatively easy to do. That doesn't really require a lot of artificial intelligence. You just select from your history of purchased items and you say, I want another one. But purchase history is not necessarily so good for predicting what a customer buys. So, for example, what's something good? Let's say I buy an electric toothbrush. So if you use a simple purchase history-based prediction system, next time I go to my favorite shopping site, it will tell me, buy another toothbrush. You just bought one 2 weeks ago. Is that a good recommendation? No, because how likely am I going to buy another electric toothbrush if I already have? If it's a regular toothbrush, it's different. So maybe not after 2 weeks, but after a month or so, it's time to replace my toothbrush. And so it's a valid prediction based on the history. So it gets tricky quite quickly. Okay, so with the remaining time, about 5 minutes or so, I would like to briefly introduce you to a few research projects that I'm currently involved with. The largest one that I'm involved with right now is AI for search and rescue. And what this means is that we are developing a system that helps people find somebody who went missing. So let's say you're going for a hike at Montaña de Oro. You tell your buddies, I'll be back by 6 o'clock tonight. And it's 6 o'clock, it's 7 o'clock. The buddy is still not back and they are getting alarmed. By 9 o'clock, they call the police and say, our buddy didn't come back. Can you help us? Years ago, the police would have said, well, it's only been 3 hours, so probably they'll come back. Don't worry about it. Nowadays, they're a little bit more careful about it, and they may look at the circumstances and say, okay, this looks very suspicious. We have to do something. Then they may inquire, and at some point, they may involve volunteer organizations, and that's where our project comes from. So it is sponsored by a Cal Poly computer science alumnus, Gary Bloom, who was very successful. He was the CEO of several companies, recently retired. And in his spare time, he was also involved in search and rescue efforts. So on the weekends and at night, he frequently went out and helped find missing people. Until now, people there use notepads and they take notes and then come back to the command post and hand their hand-scribbled notes out there while they're stumbling around in the wilderness. And then somebody at the command post is trying to figure out what the scribblings mean and how can they be put together in such a way that they can find out valid clues about the missing person and where the missing person could be found. So what we have done so far is replace the notepad and paper versions with digitized versions that you can fill in on your phone or on your tablet if you have one at hand. And then they get transmitted to the command post and they already can be pre-sorted and evaluated with respect to how valuable are they? Do they mesh with other information that we have? Are there hotspots within the search area where it's likely to find that we can find that person and so on? Another aspect is the history of search and rescue missions. So we were fortunate to have a database that somebody shared with us who collected this information of about 200,000 cases of search and rescue missions. And we're currently trying to figure out how can we use this information to predict certain aspects of search and rescue missions. Now, of course, if you have 200,000 cases all over the US, it's difficult to say most people who got lost in Montaña de Oro will be found in a particular spot, because that's not really realistic. But they could tell you based on information like how old is the person, does the person have any disabilities or illnesses, what are other features or aspects of that particular case. Oh, in this particular case, let's say the person is old and has dementia, then it's a good idea to look along a certain path, because people with these conditions follow certain paths, as our experience has shown. So that's AI for search and rescue. So this is a relatively large project, and many of our the CSAI club members have already approached me and are interested in getting involved in this project. The second one is drones for marine science and agriculture. So we have a few drones, and we had a project that was funded for a couple of years by the Santa Rosa Creek Foundation. It started out as shark spotting. So the idea was to take the drones, fly them over the coastal areas, and detect sharks in the water. It's a sexy topic, but unfortunately not very practical, because the sharks are not collaborating. And we also need lots of permissions to fly in areas where sharks are likely. So since it's easier to find cows, and Cal Poly has an educational flight range where we don't need any permissions, we're now doing cow spotting. But we're also looking at applications in other areas of agriculture. So for example, we're working with people who are keeping track of a herd of burros and wild horses in the Irish Hills in San Luis Obispo, and they would be interested in using drones to keep track of those burros and wild horses. Unfortunately, there again, we need permits, and permits are a bit hard to get and time consuming to get. So it's not quite clear if we can actually fly our drones over at the Irish Hills. Another project that I am involved with is AI for ethics and social justice. So this is not so much philosophical questions about is AI ethical. What we're trying to do is more practical. Let's say you have a project that you're interested in, and you want to examine, is it ethical for me to work on this, and what are social justice aspects that possibly might arise. So we developed a set of instruments, essentially a worksheet and a questionnaire to assess this. But now we're also exploring artificial intelligence technology, especially large language models like ChatGPT, to help us do an initial assessment of a document and then point out issues that need to be examined further based on the document or set of documents that we have. And the last one is AI for all. So that's the development of Jupyter notebooks or Google Colab notebooks that are intended for people who have limited or no programming skills and still want to try out and explore artificial intelligence. For all of these projects, you can find a Slack invite on the slides, and the club will share the slides with you so you can easily access them. You can, of course, also approach me directly, and I can get you in touch either with students or who are already working on this, or put you on meetings that we're currently holding. Unfortunately, right now, the only project that has direct funding is the AI for Search and Rescue project, and all of the funded student positions, we usually fund students on an hourly basis, are already taken up. But if you're interested in volunteering, feel free to approach me. We'll have to figure out a way of managing, especially the AI for Search and Rescue project, because if there's a lot of people who are interested but have limited or no background in AI, then we have to be careful about not utilizing our own expertise to train the students instead of actually doing the work that we need to do for the project as well. So this is a quick overview of artificial intelligence in general and the specific projects that I'm involved with. So I assume there are a few minutes for questions, and then I'll cede the stage and you can do your GitHub fun.
Yeah.
Jason.
Alrighty. Can you guys hear me? Hello. Okay. Wow, it does not want to work. Okay, I'll just talk like this. Anyone have any questions for Professor Kurfess while he is still here? And after all the questions, we will get into our Git workshop. Yes.
So as far as I know, the general impression is that it's kind of a free for all right now in terms of oversight on artificial intelligence.
Right.
Are you aware of any effort to create like a governing body or something that could have some more oversight?
Yes, so there are multiple efforts going on, and I'm somewhat familiar with the European situation, but also the situation here in the United States. So in Europe, there are many organizations and many government agencies, the European Union, involved in developing frameworks for the ethical and appropriate use of artificial intelligence. They also have some initial legislation in place, and there are also some lawsuits going on where they are trying to regulate the use of artificial intelligence. In the United States, it's more in the talking stage. So there are various committees and probably also some organizations, professional organizations, and workshops or working groups that are exploring this situation. There are also some lawsuits that were filed. For example, a group of authors filed a lawsuit against OpenAI and I believe also Google, and they claim that their works, their copyrighted works, were used without their permission to train these large language models. Of course, the problem is it's very difficult to actually prove something legally in models that are not transparent, that are driven by proprietary algorithms where you don't really know what kinds of data sets they use. But in their particular case, it is clear that some of their works were used to train these models. What's unclear is if this is falling under the so-called fair use doctrine, which the tech companies are claiming, or if it is an abuse of intellectual property and should be at least compensated or subject to the approval of the copyright owners. Yeah.
I have a follow-up question.
Okay. Yeah.
So I know in Europe, I think the GDPR is kind of an oversight for privacy, like internet privacy laws.
Yeah.
And for an artificial intelligence that's training on user data that's coming in live, like a shopping cart, say, an online site, you know if they're trying to have the users agree to have their data used for training the model?
Yes. So of course, this is the case frequently where you have to click through various permissions that you're granting the companies, and then they may or may not respect what your instructions are. But there are also some regulations that strictly prohibit certain practices. I can't really give you an example right now, but it goes beyond the situation that we also have here, where you're asked to give your permission. It prohibits some things.
I guess, Amir.
So just kind of follow on that. So like, what are they gonna do? Stop people from doing math, or like?
Yeah, that's one of the open questions.
Right.
So how can you enforce? So the first step is, can you write laws or regulations that capture what's going on and try to prohibit what is termed abusive? Essentially, what you're trying to do is you're trying to predict what people may do with the technology that currently is being explored. So that's one issue. The second issue, if you have such laws, how can you actually enforce them? And I don't have an answer to that, and I don't think anybody has. But the alternative of doing nothing is also not really a good one.
For people who are interested in research projects, but maybe have like less experience in AI, but in
Yeah.
other areas, what would you recommend, like as far as like acquiring knowledge to become more comfortable with those concepts, or just being involved in separate aspects of it that are maybe AI?
It's a bit of a chicken and egg problem. So, for example, I'm relatively open to letting people join my research activities who have no experience and learn essentially on the job, or work with somebody who has a little more experience. Of course, I'm not the only one working on artificial intelligence. There are several of my colleagues who have interesting research projects going on. Some of them are more restrictive and they only allow people to get involved once they already have some background in artificial intelligence. The good thing is it's relatively easy to get familiar with sets of tools that are available easily, for example, in machine learning or related to large language models. You don't really have to fully understand what's going on to actually use them. And what probably will happen is you use something, it doesn't work, and then you have to think about why doesn't this work, and then you'll learn more about it and you expand your knowledge and you try other use cases, and all of a sudden you're an experienced machine learning engineer and you can ask for a 200,000 starting. Those times are over. That was last year.
We have time for like one
One
more
more?
question,
Yeah,
or we can
okay.
just straight get into the Git workshops. Any last question?
Yeah.
Yep, last question.
Like most books or journals or any online resources for someone who is deployed or learn about AI.
Lots of online resources, so that's the problem. I try to keep together a few collections of such links, but they invariably get outdated very quickly. So what you could do is use one of the large language models like ChatGPT or Google Bard and ask them what are popular resources for learning about large language models. So Google Bard is a little bit better because it's more up to date. ChatGPT stops at 2021, which may or may not be up to date enough for what you're interested in. Yeah. Okay,
Awesome.
so that's it.
Yep, that's
Great.
You can
Then
turn off your
hand
mic.
over
And we'll-
the microphone.
Yep.